Today I'm going to be showcasing the process of assembling and installing brass O-gauge catenary masts. My first step in putting these together was to draw up some plans. Here's a digital version of those plans. This drawing is not to scale, but all of the numbers are accurate. Some of the dimensions aren't shown because they can vary depending upon your situation. I'll specify what I did later in the video in these cases. Here's a picture of the parts that will be used for each pole laid out on the plan so you can get an idea of what we're going for. The list of materials isn't long at all for this project. Just focusing on the pole, all you need is 9/32 of an inch brass tube stock, 1/4 inch threaded steel stock, and 1/4 inch hex nuts. Here's all of the materials together for this batch. I'm making a total of 7 poles. Here's the short piece of threaded steel and the nuts that will become our base, and attach the pole to the layout. The brass stock is cut into 8-inch and 3 3/4 inch pieces. My tool of choice here is a pipe cutter, which is a lot easier than using a handsaw. This tool will look very familiar to plumbers, and I'm glad I picked it up. It was only $14 at my local hardware store, and it made this part of the job a lot easier. After all of the pieces were cut, I started drilling the holes. I used a piece of masking tape to mark out where the perimeter of the hole should end on the upper end. And then after using the bit to get placement right and a punch to get a small pilot started, I used smaller and progressively larger drill bits to get the size of hole that I needed. You should work your way up to a 9/32 inch bit. Once you start to get to the larger hole sizes, there might be a little bit of tearing and warping of the metal. I recommend cutting away the flashing between different bits so that you'll get a cleaner result. And a quick test fit of the crossarm reveals that it fits perfectly fine. After drilling that hole for all of the uprights, I switched my attention over to the crossarms. The crossarms need a small hole in order to support the hanger, so I used my smallest bit and set the hole about 3 inches away from the end of the crossarm. This is a dimension that is not on the plans, and you could set it at whatever distance away from the end of the crossarm as you'd like. Here's the finished pieces all pressed together. If you drilled the holes right, there should be a nice friction fit between the two, but obviously this won't be enough to support these for long periods of time. So the next part of the process remains, soldering. I've made soldering jigs out of pieces of scrap plywood. These are basic handmade tools that will really aid in the soldering of these poles. I don't have any specific directions on how to put these together, but the first jig you're going to need to make is simply a hole drilled in a piece of plywood, supported on both sides with another piece of plywood. This jig is used to assist in the soldering of the base to the upright of the pole. You insert the base in with the threaded steel stock and tighten the nuts on both ends. Sand the surface of the nut on top because that's going to be soldered. Then I sanded around the bottom of the pole because that will also be soldered. I applied a thin layer of flux to everything. Now the process that I have detailed here is for using an electric soldering iron. Although this process would likely be much faster and maybe more effective through the use of a propane torch. But I figure a soldering iron is a much more accessible tool for people, and also we aren't quite equipped for using a propane torch currently. Initially your joint doesn't really have to look that pretty, it just has to hold okay, and these seem to hold okay. Obviously you can find detailed instructions on how to properly solder on the internet, and I am by no means an expert. I frankly suck at it, but I've managed to make these work okay, so I figure pretty much anyone could make these work okay if I can. Now that all of the bases have been soldered, it's time to turn our attention to the joint between the upright and the crossarm. The other incredibly helpful jig I've put together makes sure that the arm stays at a right angle to the upright. Obviously the same prep needs to be done to the pieces before they're soldered together. Here's a finished joint, and while it doesn't look good, it holds. Here are the poles with all of the joints done. In order to finish the joint at the base and the joint between the crossarm and the upright, you can use a file and sandpaper to get the right look. It doesn't have to be absolutely perfect, and depending upon how good you are at soldering, you may have to do more or less finishing work. I absolutely hated this part of the process, but in the end, it's certainly necessary. And having a Dremel with a sanding bit would definitely help with this job, which I currently don't have, so I had to make do with the file and sandpaper. Maybe eventually I'll take another stab at finishing these. The next part of this process was putting together the hangers. I used galvanized steel wire to do this. You could use any thin, relatively stiff wire to get this done. But in order to key into the system that I've been building, which uses HO rail, I have an HO rail joiner attached to the end of this hanging wire. This will be attached to the pole shortly. The height at which you attach these to the pole really depends upon how tall your track is and how tall the pantographs reach on your locomotives. It also depends on personal preference and if you'd like to run overheight rolling stock. So I'm not going to be detailing that part of the process in this video. That's something I think people would have to figure out themselves. And my case here is a special case as well, for a lot of my locomotives have been modified to run on my existing catenary, which is pretty tall, so I don't think I could in good conscience give numbers that won't work for the majority of people. Once I had soldered the hangers onto the pole and had finished the joint, it was time to give these a coat of paint. Mask up the rail joiner area of these, as well you don't want that to get paint on it because that's where you're going to have your contact. In terms of paint color, you can get as creative as you want. Of course, they all have to start in primer if you want the paint finish to last and be very durable. So far, I'm going to stick with primer gray for my catenary masts, but it's really up to you. Light blue would be a nice color for catenary masts, along with black or brown, or even maroon. Maroon would look very nice. I've seen some people pull off minty green, and it looks great. It all depends upon what your layout is like stylistically and what you personally prefer. The catenary on a layout can really help define it, and adding color to it can define it even more. Now for the installation of the poles. For most layouts, this is a very simple process. My layout is a little more complicated because I have pre-existing catenary that I need to take down in order to put these up. And the positions of the new poles are relatively reflective of where the old poles once stood. I've decided to position the droppers directly above the middle rail. This should suffice for most layouts. If you've got a large layout or have a feeling you'll be running trains a lot, or you just want to model this feature of real-life catenary, you can stagger them so the wire will zigzag across the width of the pantograph and have more even wear and look more realistic. But to keep it simple, I'd say just keep it over the third rail. My layout has extra complications around the curves, which I need to take into consideration, because my curves are banked or super elevated. So I've set my wire pretty far inward of the loop, because the trains are at an angle and so are the pantographs. So in order for the wire to make reliable mechanical contact with the pantographs, it has to be shifted. Depending upon your layout, the placement of the poles is a factor that can widely vary. In terms of the distance apart, it depends upon the length of rail you're using, if you're using the HO rail system. About 10 inches apart is standard for HO rail. However, for the straight section of my layout, I've soldered two pieces of 10-inch straight rail together in order to get roughly 20-inch segments. Again, this is a step in the process that will vary wildly depending upon the layout and the hobbyist doing the work. When using HO rail as a contact wire, visually it's important to paint it black so that it doesn't look bad. I'd recommend using spray paint for this process, as I've used acrylic paint on these before and it tends to wear off pretty easily. Just make sure the contact area on the underside of your wire is clean. You could paint the dropper black, which I would recommend doing, since it makes it blend in with the rest of the wires. I'd say acrylic is perfectly acceptable for this. The last steps are cosmetic details that will help make the catenary look much better. I got this flexible hollow black tubing from a craft store. Its original intended purpose is to be used when making small bracelets, but here we're going to use it as our secondary wire, or catenary wire. For those that don't know, catenary is the name of the shape that a string makes when it's held by two ends. One optional modification to make the system look more dynamic and realistic is to make small hooks that are soldered to the top of the contact wire. You can fashion these in any way you like, just as long as it's able to hook onto the hollow tubing. This will help pull the tubing down and give it the catenary curve look. Now that they've finally been installed, well, they look good. They should be very robust, and they should last for a very long time if you got the solder joints right. You'll be able to reuse them from layout to layout, which is something I like about these, which is something that you couldn't really do with the fragile poles that I had built before. In fact, when I was taking some of these poles down in order to put the new poles up, they fell apart. So I guess it's a good thing I got a jump start on building a new system. This is one that I'm actually quite proud of. Not to say I was never proud of the first system that I came up with, but this one is just a higher quality piece in general. Well, I hope this was helpful if you're planning on putting wire up on your layout. If you have any questions, make sure to let me know in the comments, and I'll try to help you as best I can. It's a little difficult to do it through the medium of YouTube comments. But anyways, thank you for watching and have a great day.